All right, welcome to the Pod Security Policy Replacement Breakout session on March 10th. Jordan, would you like to kick things off with the demo?
I would.
I guess just as background, I sent out a proposal for sort of take the bare minimum approach that I had proposed initially, add in restricted, add in versioning, add in a lot of nice quality of life features, and you get the new proposal. Jordan has a demo implementation of that.
Let me see if I can share my screen. I cannot. Can someone who is the host allow me to?
Just made you a co-host. Try again.
I'm sorry. 1 second. How's that? Can you see my screen now? Yep. Great. All right. Hopefully you had a chance to look at the doc. So this isn't just coming in cold, but if you didn't, the 5-second version is this approach controls policy based on labels on namespaces. It follows pod security standards in terms of buckets, like 3 buckets: privileged, which allows anything; baseline, which allows baseline stuff; and restricted, which is a really locked down, like you must constrain permissions and like put a lot of controls in place. And then it handles the thought that we would have to change what the restricted policy and maybe the baseline policy look like over time by adding support for optionally pinning to a particular version of those policies. So I actually 1 second ago reverted to an older version of my branch because the latest version wasn't working. So this is going to be super exciting. To kick this off, the labels that were proposed look something like this. I just made a bunch of namespaces so you can kind of see what expressing this policy would look like on different namespaces. So here's a namespace that doesn't indicate what policy level it wants. And so I don't have the pod security Kubernetes IO label on that namespace. Here's one that explicitly wants to be privileged. So it is setting its enforce level to the privileged policy. Here's one that explicitly wants to be baseline. So it's setting its enforce level to the baseline policy. So far, that's pretty straightforward. Only the privileged namespace will allow anything. The baseline namespace will only allow pods that fit inside the baseline policy. But as we've talked about in this meeting, we also want the ability to sort of dry run policy or see what the effect of a policy would be without breaking the world. That's important to be able to safely transition onto this mechanism, or just, I mean, quality of life in general, like safely apply policy changes over time. And so this also allows, rather than enforcing a given policy level, it allows warning on a given level. So this namespace is saying, I want to warn about pods that don't fit inside the baseline policy. And then the restricted namespace is only allowing pods that fit in the restricted level. And then this is what it could look like to pin to a particular version of the restricted policy. So the way you say you want to, use the restricted policy is the same, but you also can say, I want to use a particular version. So I had to go pretty far back to find a change in Kubernetes that would have trickled into the pod security standards. But in 1.7, the allow privilege escalation field did not exist in pods. And so obviously in the 1.7 timeframe, we wouldn't have had an opinion about whether you have to set that field or not. In the 1.8 release, we added that field, and restricted pods should prevent privilege escalation. They should set that explicitly to false. And so that would be a good example of, like, prior to 1.8, we didn't have an opinion about this, but in 1.8 and onward, we did. So I've got these namespaces set up. I don't actually have any pods created, so I'm going to walk through what it looks like. Here we go. To create different, or to try to create different pods of different privilege levels in all of these namespaces. So first of all, I've got a privileged pod, which is privileged. I've got a baseline pod, which is just a sort of standard pod. Like, it's not opting in to host visible stuff, but it's also not like setting super strict controls, like, you know, allow privilege escalation. And then finally, I've got a restricted pod, which is opting into tighter controls, like allow privilege escalation false. So I'm going to, this is fancy stuff to say, try to create the privileged pod in every one of those namespaces. And so I'm going to step through and see what happens. So can I do it in my namespace that didn't express a policy? Oh my, oh demo gods, you have failed me. 1 second, I am so sorry. I'm gonna have to restart.
Any questions about what you've seen so far while Jordan restarts?
This was my mistake. But yeah,
No
let's
worries.
mix questions and demo. How about that?
Or thoughts, comments, concerns?
I just want to praise the digging into the history to find the 1.7 to 1.8 transition for this, like, to make it really realistic. That's like, that's a good level of dedication.
I would say thank you, except that's less dedication and more just pain. Like, I felt pain like that over the years, so it's really just me going back through painful memories.
And you did that for all of us.
Yeah.
Jordan, a related thing to that, did we, so in PSPs, I remember we special case, like, oh, if you said you could do a secret volume mount, it means you can also do like the projected volumes that also do the secret or whatever, right? Does that kind of fall into the same bucket of like things that, I guess that didn't necessarily change, we like adapted the meaning of an existing policy to mean?
Yeah, that's a good question. So part of being, so the pod security standards are much broader than pod security policy. Pod security policy gave you like super fine-grained control, like this volume type, but not that volume type, this volume type, but not that volume type. And so we had to do sort of strange things to map those very fine-grained volume types to new capabilities that we were using by default. Let me see if this works now. Oh, oops. Yay, okay, back on track. All right, so I can create a privileged pod in the namespace that didn't have a policy level. I can create one in one that was explicitly privileged. When I try to create it in the baseline namespace, I am forbidden, and it tells me this pod is not allowed, and it tells me why, because it has privileged containers. So now if I try to create it in the namespace that was only warning about the baseline policy, I'm actually allowed to create it, but I get a user-facing warning giving me the same information. And so you can imagine an administrator who was planning to tighten down policy could put a warning level on their namespaces and then send an email to their org saying, like, in a month, we're going to be going to the baseline policy. So, you know, run your workloads, run your CI tests, like do whatever you're going to do, file a ticket here or make changes if you don't fit inside. So this lets you have a user-facing warning without actually disrupting operations. And then similarly, it's rejected for the restricted namespace, it's rejected for the restricted as of 1.7 namespace, allowed with a warning in the restricted warning namespace. And so something similar for the baseline pod. It's going to be allowed in more namespaces. It's allowed in my baseline namespaces. It's forbidden in my restricted namespaces. And the reason it's forbidden in the restricted namespace, you can see it's complaining that it didn't opt into that allow privilege escalation false field. When I try to create it against the restricted legacy namespace, that message is not there. So the restricted legacy, the restricted policy as of 1.7 didn't know about this field. So even though my pod didn't opt into it, it wasn't complaining about that. All right, so as you can see, I wasn't able to create baseline or privileged pods inside my restricted namespace, only in the one that was limited to warning about it. And actually, one of the cool things I wanted to do looks like something that just merged into the master branch may have broken. So I need to investigate that after the demo. But I can show you some of the other things that this lets you do. So because the policy, the way you specify like what policy applies to a namespace is based on labels, you can use label selectors to easily find like namespaces that have different policy associated with it. So if I wanted to find a namespace that was explicitly using a version of a policy other than the latest version, I can do that with a label selector. I can say find namespaces that are enforcing that have specified a version where that version is not latest. And so right away I can see like this restricted legacy namespace pops out. It makes it really easy to find namespaces that are pinned to older versions and then gradually like focus on migrating them or figuring out what's going on with their workloads. So you have good visibility to what is being enforced and good visibility to be able to query and identify namespaces that aren't compatible with the latest version. So the other interesting thing that we can do with this, besides just querying and having sort of dry run that's user facing with the warnings and dry run that's admin facing with audit, we can dry run changing policy. So because policy levels are specified with labels on namespaces, the way we would change those is by relabeling the namespace. And so if I wanted to change all my namespaces to be the baseline policy instead of the privilege policy, or instead of whatever they currently were, I could just label them all, to baseline and then see what broke. That would be bad. I could warn, I could say start warning at the baseline level, and then hopefully some human user interacts with this namespace before I decide to like actually make this effective and notices and does something about it. I could audit at the baseline level and then watch my audit logs for a while and hope that some automated process or some user did something that would make the fact that there was stuff in this namespace that would be disallowed by the baseline policy, it would make that show up my audit logs. But what would be really great is if I could check if there was currently stuff in this namespace that was going to be disallowed by this new version. And so even though the way I would do this is by labeling the namespace, we actually can dry run API requests. And so I can send this label request to the server and say, like, hey, dry run labeling these namespaces, but don't actually commit it. Like don't actually change the namespace. And because the admission plugin that's responsible for enforcing this policy on pods is also looking at changes to namespaces, it can detect when we are changing enforcement level on a namespace. And it can do its own check of pods that already exist in the namespace and give us warnings if any of those would be disallowed by the new policy level. So if I were to relabel all my namespaces to start enforcing at the baseline level, these are current pods that would be disallowed by that new policy. So in my no policy namespace, I had a privileged pod. And if I tightened enforcement on that namespace to the baseline policy, that existing pod would be disallowed. So this could be disruptive for that namespace. Similarly, I've got other privileged pods in other namespaces. So this lets me, this is one way to sort of see, are there currently things that would have problems if this new policy was enforced? Anyway, that is in a few minutes, kind of how you select policy levels for namespaces, the things you can do, you can enforce, you can audit, you can warn. We handle the versioning issue by letting people pin to a particular version, like the policy as it existed in a particular version. That makes it easy to decouple cluster upgrades from fixing all your workloads. Like if you're about to upgrade from 117 to 118, and you're like, you know what, I don't know if I haven't had a chance to go read the 118 release notes. Like they were 40 pages long, and I just didn't have time. You can pin your namespaces using the latest policy to v117 and do your upgrade, and then come back later and dry run or audit at the v118 level. And if it's clean, then you can unpin, put it back to latest. But unless you decouple that or do it namespace by namespace. That's all I got.
As a longtime ops person, I want to register how much I appreciate the code in the admission controller that re-examines the pods in the namespaces on its own, because I would totally do that with some awful kubectl get pods YAML pipe to sed pipe to kubectl dry run garbage, and it's just so nice and clean to have that as a built-in feature.
One thought too is that my tendency would be to implement this in terms of v1 pods and put the code in a location that it would be easy to run as a controller as well. So if you wanted to have a controller that was sort of sitting off in the background, checking pods and checking namespaces and saying hey, this thing looks out of compliance with that.
You could just vendor in that package and go.
Yeah, I think having it be able to be an asynchronous watchdog or be this synchronous dry run thing, supporting either approach seems useful.
Sorry, I'm just catching up here. So this may be a stupid question. So is the baseline policy something that will be shipped by default? Will there be multiple different policies?
Yeah, so this maps to the pod security standards document that defines 3 policy levels. So privileged allows anything, restricted is pretty restrictive. You have to opt in to sort of less privileged than a default pod. And then baseline is sort of in the middle where it cuts out a lot of the host visible things like host path volumes and host ports and things like that.
Okay, all right, thanks.
And privileged containers, yeah.
Yeah, so I think from an SELinux perspective, maybe we may want to disallow unconfined type in the baseline. That would fit in the privileged.
Yeah, there are definitely a few things in pod security standards that are a little hand wavy right now. SELinux is one of them. And then so if we're going to actually have a reference implementation, we certainly need to pin those down. So yeah, feedback from folks who are familiar with SELinux on what would make sense there would be very welcome.
Okay. Sure. Yeah, we'll read through it in more detail and add comments there. Thanks.
One more for you. First, cool demo, Jordan. That went off really well. Minus the first little hiccup. Like what I'm seeing, I haven't quite got through the whole doc. Looking at the last 2 pages, the key design decisions. Not a hard stop, but are a hard blocker. But the phrase unconfigurable and just what's going on in there with that at least gives me a moment of pause. I don't have anything directly against it, but it's I could see that possibly causing issues for some people, but I don't have a use case for it yet.
Yeah, I think unconfigurable. I mean, I don't think it means that strictly because it does call out like specific dimensions that I think makes sense to allow bypassing on. I think that's speaking more to the rather than being able to express every atomic aspect of the policy in a API facing way. This is proposing like sort of very coarse buckets and saying like, these are the buckets that are provided. If you want to bypass this, here's how you can bypass it. But that's the difference. Like, are we looking for something that exposes every facet?
No. And I think I'm just sort of sounding it out. I might not have something here. I'll be very, very transparent. The thought in my head is I think if I translate what you're saying there is we know we want to ship with something which is secure by default and has the 3 buckets in it. I guess where the part where I get a little sort of need to head scratch is, do we want to tell people if you're not in those 3 buckets, you need something more, you should go get another tool?
Absolutely, 110%.
Cool.
And the goal is to make it reasonable for this to coexist with another tool. So like if there's a particular namespace that you need to use another tool with for some reason, the namespaces was one dimension that was called out, particular users or particular runtime classes. Like those were categories of things where we see existing use cases where like a different policy tool would be needed to do like pretty niche or pretty domain specific policy. And so being able to coexist without complicating the built-in thing is what we're going for.
And then also making it as easy as possible to do a wholesale replacement if you want to. And so I think that gets called out in the flexible extension support section of the doc, where we would have, offer this as a library. So if you want to, take what we have and then customize it with your own policies, that's an option. Or if you want to, do a completely separate implementation, we would publish the policy definitions in the policy definition as spec, so that they could be easily replicated, and also publish a series of test cases that could be run against that to make sure that you're, if say you wanted to re-implement this in OPA, so that then you could like layer on some additional logic on top of that, you could kind of easily, or as easily as we can make it, port that logic to OPA and then run the test cases against that configuration to see that it's the same. But I think it's important, like this is the key distinction, I think, between this proposal and the PSP++ proposal, is how configurable we make it. And by being more constrained with this one, we have more freedom to do kind of fancier behind-the-scenes logic around versioning, and maybe to a lesser extent dry run. But I think versioning is the one that becomes really hard with the more flexible approach.
The other thing that had been mentioned, like the wholesale replacement by an external policy tool, if an external policy tool wants to have a reasonable ramp from, like, I started with this, and then I moved to an external tool that has maybe more flexibility, it would be nice if the external tool could sort of apply these policies modulo like some differences, the ones that I guess prompted you to move to that tool. The smaller the surface area of this API or this built-in thing is, the more reasonable it is for an external tool to say, yep, we support that, plus these differentiators that are more powerful or flexible or whatever, so come use us. If the API surface is sort of unbounded or combinatorially gigantic, then it's very hard for an external tool to say, oh yeah, like just drop us in, we're a drop-in replacement. We support all of the surface area of the built-in thing plus our own stuff.
David?
I was just going to say, I like the hard-coded aspect that makes it easy to understand. I like the fact that coexistence is very plausible here, and that an on-ramp exists. I did have some questions about where this varied from the original minimum viable pod security policy. So one thing that stood out to me was runtime classes. Runtime classes are created in the API, and as I recall, Tim's original proposal wanted to have either a label or an annotation on them indicating I want to be exempt or I don't want to be exempt. Is this moving away from that, or is that still open for discussion, or what?
I'll answer that, and then to Sir Talk. Sorry, I'm probably pronouncing that wrong. So first of all, that was an optional extension for the bare minimum proposal. So the idea there was a label or an annotation that says, whether to exempt the enforcement or not. We could kind of port the same mechanism in this proposal to the bare minimum one. To apply that approach to this proposal, we would probably want to say exempt from which level on that, or we could do that. But the goal that we had with the exemptions was to make them as explicit as possible, and two, to kind of prevent that indirection. So if you're just exempting based on runtime class name, that's on the pod spec, and so you can go straight from. You can make your decision by only looking at the pod spec. As soon as you start looking at labels on the runtime class, then your out of tree, your extended implementation gets a bit more complicated because you now need to be able to look up runtime classes if you want to do that same approach.
I think if we decide to go with this, I'm going to have some follow-up questions about that. One of the things we've had to deal with in API machinery is cases where you can create thing X in the API and you have to set thing Y on disk, and it's a little bit of a mismatch, and sometimes that mismatch is warranted, right? Like sometimes it's a different person who should decide what these qualities are. I'm less sure of that with regard to runtime class.
One thing I'll mention that I like about that is regardless of which people are supposed to be making those decisions in an authorized fashion, having part of it outside of the API affects who can make those decisions in an unauthorized fashion when they have unauthorized API access.
Yeah, I think this is one of those details that would be good to follow up on if we want to move forward with this. There's a handful of kind of implementation details that need to be resolved. So, Sir Talk, to you.
Hey, looks like we are recording the violations as part of the prefix audits annotation. So my question was, are we concerned about the etcd limitations here?
So audit annotations don't hit etcd. They get sent to your audit log or your audit webhook. This is actually not a mutating webhook, so it doesn't modify pods at all.
Oh, I see. I thought this was modifying the pod spec, but you're saying they get sent to the audit logs.
Right. So if it's user facing, it comes back in a warning header. If it's audit facing, it goes into the audit log, which gets either written to a file or to your audit webhook. And then if it's enforcing, that just, I mean, it comes back in the error message to the user. And I think it actually goes into the audit log as well. But yeah, none of this touches the pods themselves or etcd.
Thank you.
Jordan, I had a question on the, it's covered a little bit in the doc about how it would apply to like deployments and daemon sets and everything, right? Because you're not supposed to be directly making pods, because that kind of silly.
Right.
How, I did not understand the logic in there for how we would help CRD authors have the same benefit of this.
Yeah. So this, I would actually like to see CRD authors stop embedding PodSpec and start using pod template. We have an object, like a typed API object, that has all the validation of PodSpec and is built in and is just an inert blob of a PodSpec. I would love to see CRD authors use that. And so if you had a CRD that was needing to stamp out pods, like you would create an instance of the custom resource with a reference to a pod template. And so you would create both of those objects. That would give us a built-in type, which we already have, which we could do validation and warning, and like it would shrink the size of your custom resource schema by like a megabyte. And would give us a hook that something like this could warn about, like, hey, you're creating a pod template that if you create a pod from it, it won't be allowed. And would also give a target for a CRD to, or a custom resource to reference. That would be my recommendation for a lot of reasons, like the schema size and the validation, and like for a lot of reasons, but also for this reason.
So what are the next steps here? I guess, are there any, beyond kind of some of these implementation details that we talked about that need to be resolved, are there any concerns about this overall approach? I think the configurability question is kind of the big one that stands out to me.
One thing that we didn't talk about yet. So if we're looking for like ease of transition for people currently using pod security policies, the PSP++, because it's basically schema compatible, simplifies the definition portion of it. People currently using PSPs would still have to like rework their bindings, and if they had non-homogeneous use in a namespace, would still have to resolve that issue. But at least the definition part, assuming they weren't using mutating bits, would be pretty simple. Something like this, I think we could still be able to have a mapping that would look at a PSP and say, like, which bucket would you fall into? But it's not quite as straightforward. I think we should do something like that.
It's like a ceiling function, but for policy.
Yeah. I mean, you could do it both ways. Like you would have to give the ceiling and the floor. Like, I don't know which you care about. This falls in the middle between these two levels. To be as restrictive as this PSP, you would need this lower level bucket. To be as permissive as this PSP, you need this higher bucket. But I think we should provide something that could tell users that. But so that what the transition from PSP to a thing looks like would look different for PSP++ and this.
Would you imagine that, like, I don't know, as a little Go program that vendored in the PSPs and also vendored in this, and then, like, I don't know, got stuffed into Hack or something?
Yeah, I mean, we've released one-off tools. We had one for fixing up client Go calls when we added context. We had one for identifying bad owner references when some garbage collection bugs were fixed. This seems like a reasonable thing to let you run that can look at your PSPs and say, like, here's where they fall out. And because PSP actually annotates pods on their way into namespace, it could, if you wanted to, it could look at pods in a namespace and say, like, and then trace it back and say, okay, the pods in this namespace were admitted by these PSPs and their levels are here. So this is the most permissive level and the least permissive level, like, to allow all the current pods or enforce on all the current pods. So
I like all these ideas, and I want to make sure that they're written down in a, like, optional extensions part of the document or something, so we don't forget about them.
They are. There's a PodSecurityPolicy migration section under optional extensions. I tried to capture a bunch of ideas of what a tool could do, as well as a potential migration workflow. Feel free to add to that if you have other ideas of how we might make that transition easier. Mo, I think you're up next.
Yeah, I was going to make a small comment that, like, I know the configurable or non-configurable is likely going to be decisive, depending on, like, what your desired use case is. I think David already said this, but I personally feel that the lack of configuration is what makes this, like, sort of a good solution to, like, be in tree and sort of help you get started. Like, to me, it kind of mirrors RBAC. Like, RBAC is quite configurable, but you can only go so far. Like, you can't start defining field level policies. You can't, like, there is just a limitation. Like, you can't also do anything, like, with UIDs on users. You can't do anything with extras on incoming users. Like, it has a, like, an upper limit of, like, the level of policy it can express. So even though it's configurable, like, once you understand the building blocks, it's relatively easy to understand what a policy will do. And it also helps that it's only additive, that there's no denial logic. So it's, like, relatively easy to understand. Right? In that regard, the lack of configuration makes it so you have a reasonable chance of understanding what will happen, and the lack of mutation. I think that's a really good property.
Oren?
Yeah, first, super cool. I really like the demo. I'm wondering if anybody has concerns around using labels on namespaces as kind of the opt-in, opt-out mechanism in terms of the granularity of the kind of authorization you can do around that, and whether that feels like a privilege escalation from what we assumed the ability to create namespaces was in the past, versus what it would be if you can create a namespace with this opt-out that lets you run root on clusters.
Since so many other things are also around namespaces, and a namespace is such an important cluster scoped object, I would get the feeling that in almost any cluster, if you can create namespaces, there's already more horrible things you can do than that. And so, like, personally, I feel good about it, but also happy to hear anybody else's thoughts on that matter.
Yeah, this has definitely come up in the context of network policy, which is another policy resource that is kind of based on labels on namespaces. So it's definitely a concern. I'll dig up the discussion around what to do about network policy and link that into the agenda after this meeting, because there's some interesting thoughts and conversations around it there. I if this is something that we wanted to solve, I'm not sure it makes sense to solve it as a one-off for this or for network policy, but rather to kind of take a holistic view of how to control labels on namespaces better. Ryan?
Yeah, I just wanted to kind of add a counterpoint to Mo's previous of the limited configurability. I guess food for thought is that it kind of, since there's only 3 and they're hard coded, it kind of inherently, whether it's not intended, it's like these are the official graced, policies for Kubernetes. And from, the reality of most enterprises, the security people are not necessarily Kubernetes experts. And so they're going to say, oh, do restricted, call it a day. That's all you get to choose, at least in my experience. So I just, throw it out there as a counter to the limited configurability.
It is true that, yeah, a lot of our customers say default to restricted in the SCC restricted, and I kind of need to wrap my brain around whether this new proposed restricted is more or less restricted than that one. But it is true that tends to be the security team's perspective, right? You start with the most restrictive policy. I'm not sure that's a bad thing unless it's not restrictive enough.
The difference between restricted and baseline, there's basically 2 main things that restricts beyond baseline. One is requiring all containers to run as non-root, which ends up being usually the hardest thing to do. The blocker for using restricted. There's a lot of containers out there that expect to run as root. The other one is preventing most of the volume types that aren't the sort of built-in API style volumes. So secrets, config maps, empty dir, projected. And it says that for anything beyond those, you need to use a persistent volume. So those are the main 2 differences there.
And okay, that's helpful. And what's the degree of, and I'm sorry, I can go read this after the fact, but I need to go through the list of, how limited is access to the host, because that's the other area that security teams really focus on. They want to be sure that not just, host network, host file system, host PIDs, right? As much as possible.
So most of the host boundary items, like host path and host network and host PID, most of those are actually included in the baseline policy. So
okay.
In generally, the volume thing is probably the biggest exception, but generally the baseline policy says, like, what are the capabilities if I just created a pod without explicitly escalating my namespacing or privileges? Like, what would I get? And so if you just create a pod and you don't opt into some of those host level things, you don't get privileged, you don't get host PID, host network, things like that. And so that's what the baseline policy tries to keep you at.
Got it. Thank you.
On that note, are there any concerns with interactions with existing pod security policies, modifying defaults, changing the assumptions of the profiles?
You're talking about like the mutating aspect of pod security policies? Yeah. So I think there was agreement that we don't want to mix policy and mutation. If someone is running pod security policies that are stumping fields and pods, or like forcing mutations onto pods, that's in many ways, that's one of the ways I think the pod security policy API went off the rails. Like there were just so many ways to express that, and the API to express mutations to an API has to be more complex than the API it's modifying. And so that seems like a good candidate for like adding something, a custom admission webhook. Like if in my org, I'm going to stomp SELinux labels based on the namespace, or I'm going to like stomp a random UID, or I'm going to like assign these things, that seems like an excellent candidate for putting your own admission webhook in. And because mutation happens before validation, that will happen prior to this running. And so if this thing is going to say like you must run as non-root and you want to be restricted and must run as non-root, and you know that even though your developers are lazy and aren't like explicitly doing that, but you've been like you've had PSPs in place to stomp that into pods, you can put your own thing in place to keep stomping that in, and it'll be effective so that they can pass the restricted policy, because mutation happens before validation.
Okay, I was just, I guess, asking if that's visible to this webhook, and if so, does it need to? If not, does it need to somehow take that into account? Is the fact that another admission plugin mutated visible to this webhook, or visible to this? Specifically pod security policies. I didn't remember if those were visible down the chain or not. I mean, the changes they make are visible. Okay. In general, admission can't distinguish between what the user sent and what some earlier admission plugin fiddled with. So they have to make their decision based on the current state of the object that's being admitted. So if the thing upstream of this made changes that it's happy with, then great, it gets allowed. I think the important thing to add there is that all mutating admission webhooks run before any validating admission plugins. So all mutate, by the time it gets to this, there's not going to be any more mutations happening afterwards. Thank you.
So, this may have been discussed, but I have a question regarding like kata and runtime classes. Any thought has been given to that? Because when you introduce a VM into the picture, you can like allow the container to do anything. It can be privileged. It can get anything inside the VM. So it doesn't cleanly fit into these classes.
Yeah, Tim or David, you want to take that? I think you've raised these.
Sure. So coexistence was thought of like at the beginning of how we manage this. And I see two plausible outcomes. One is that we build a completely different system for managing these cases like kata with these different runtime classes. And the other is that we build a system that actually builds on these labels, right? Which I see as the most likely. I think that no matter what we do, we're likely to end up and say, like, this default admission plugin, it is going to ignore this runtime class. It will never learn about this runtime class. It'll never learn about your runtime class. But if another admission plugin were developed, it could use that same intent of this namespace label. I see that it is green or restricted, and I will apply restricted for whatever that means for my runtime class. That may involve some consideration of default allow and default deny, but I think that system works really well for users and would actually help us build out a set of runtime class admission plugins. Okay.
So they would end up looking at the same labels and then interpret them for the runtime class.
Open to negotiation, but I think I would probably start there. Like if I were an author coming in, I didn't have my own distro, I would almost certainly start there and say, as an on-ramp, this intent fulfills what I mean. And so I'm going to put on another admission webhook that prevents any random runtime class from bypassing, and then I'm going to honor this label. That would probably be how I would try to tackle the problem.
Yeah, it doesn't promise anybody would do anything, but it provides them an example of something they could do, and it encourages that kind of UI.
And it's a constrained enough space that it's like, if I had to map the PodSecurityPolicy API to gpiser, like, I think it gets into what Mo was referencing, where like PSP makes very specific promises about like, we will allow exactly these volume types. And so it's super confusing, like when a new volume type gets introduced that sort of is like, well, if you could create a secret volume, why can't you create a projected volume that pulls in content from a secret? And so it's, should we allow that? I don't know. Like, if you look at the PSP, it's making very explicit, specific promises. Having this sort of bucket system that's more coarse-grained and more like philosophically driven, like baseline sort of limits a pod to baseline capability and prevents host access, and restricted opts into these tighter controls. Like that's easier to map to like a different domain, like Kata or gpiser or something.
Because it's vaguer. You can translate it philosophically.
Yeah. Yeah.
Tabitha and Ian, not to put you on the spot, but as the authors of the PSP++, I'm particularly interested in kind of what you think overall of this approach. Is this a happy medium between PSP++ and bare minimum? Or do you still think that there's a need for the finer grained configurability?
And it's fine to not answer. Please don't.
I mean, my personal opinion is that this is better than either one of them, because the PSP++ was really based on the idea of making the on-ramp as easy as possible and giving it enough flexibility that people could choose what they needed, but it had enough flexibility that I think it made it unclear for users with a certain level of complexity whether they should build that out using like PSP++, or whether they should turn off PSP++ and go and use Gatekeeper or Caverno or Krail or whatever. And the bare minimum one, I felt didn't have enough flexibility to have it be useful for as many users as I would hope. And so I feel like that this solves both of those things by having much more flexibility than bare minimum, but also having really hard edges of how fancy you think you can get with it. So then it's easy to look at it and say, but we absolutely need foo. And so we should go and use something that's complex enough to let us do that. So I'm delighted with it. It does all of the things that I really wanted with a lower level of user-facing complexity, and honestly, a lower level of developer-facing complexity. Less so for us as upstream Kubernetes maintainers, but more so for the maintainers of Kubernetes distributions, where if we shipped PSP++ the way that we wrote it, there's a lot of opinions that distributions need to come up with of like, well, which bindings are we going to make by default when we install a new cluster, and so on and so on. The lower flexibility here makes those decisions easier, like makes it so that we can even make some of those decisions.
Tabby was far more articulate than I'm going to be today, but I also really like it. I think it is a happy medium, and I think it's really smart in the way that it's implementing things, and like, I'm for it.
All right, thank you. So based on the reactions that I've seen today and the feedback we've gotten, I'm going to propose that we move forward and bring this to KEP. A in the interest of not making decisions in meetings, I think I'll send out a survey to the SIG-Auth and SIG security mailing lists, just kind of asking for any kind of outstanding concerns before we bring this to full KEP review process and kind of move forward with it that way. So keep an eye out for that. And otherwise, thank you everyone for joining today.